All right, now we're going to talk about pH. So pH determines how acidic or basic something is. So basically what that means, when water mixes with certain substances, it's actually going to break down. So water is H2O, so you've got two oxygens and a hydrogen. Well, water can actually break apart. And when it's going to break apart, it's going to break into separate hydrogen, which is H plus, or hydroxide, which is OH minus ions. So remember, an ion is just a charged molecule. So it's going to break into these charged molecules, these ions of either hydrogen or hydroxide. Now, this makes water become either acidic if it's adding hydrogen or basic if it's adding hydroxide. So it's all color-coded. So where you see red, think hydrogen, and acidic. If you see blue, think basic and hydroxide, right? So I would recommend that you color code this in your notes as well. Now, we judge pH on what's called the pH scale. So the pH scale is just a number line that runs from 1 to 14 and all the decimal points in between. So something can have an acidity of 3.5, or it can be basic with a pH of 11.7. So numbers and all the decimals in between. Now, it goes from 1 to 14, with 1 being the most acidic, 14 being the most basic, and 7 is neutral. 7 is neutral. A really great way to remember which end of the scale is which is to just draw the scale on your paper, and A comes before B. So A for acidic, B for basic. If you just go left to right on your scale, you'll end up in the right place. So those acidic numbers are going to be low, our basic numbers are going to be high, because A comes before B. Now, as you become more acidic on the scale, that means there's more hydrogen ions in that substance. So things like lemon juice, carbonic acid, which is actually acid rain, all of those really acidic things are going to have more hydrogen ions. They're going to be on the low number side of the scale. They're going to be acidic. Now, our basic things like bleach or ammonia, are going to have more hydroxide ions. So they're going to move up on the scale, right? They're going to move towards the 14 end, the more hydroxide ions they have. Now, when you hear acid rain, I mentioned carbonic acid just a second ago. Carbonic acid is actually where carbon dioxide is going to bond with water, and that's going to break it apart. That's going to separate some of those hydrogen atoms. When it does that, it becomes more acidic. So acid rain is literally acid. It is going to be carbonic acid, which is going to be on this side. The more pollution you have, the more carbon dioxide you have, the more hydrogen atoms are going to break off that water. Because more CO2, you're going to see more break off, you're going to have more hydrogen atoms. So more pollution, more carbon dioxide that we pollute into our atmosphere is going to result in more acidic rain over time.